Welcome to the third Arachne tutorial. In this video, we will cover getting your robot to drive using Arachne. The first step is to create a new subsystem package which will hold our drive subsystem. Then, create a new class, preferably named something similar to subsystem driver. Make sure that it extends subsystem base, which is an Arachne class. Now, we have to create the motor controllers for our drive motors. We do this by creating an instance of control drive. The parameter will be a new instance of whatever motor controller you're using. In this case, we're using a Talon SRX, which is represented in the code by the CanTalon class. If you don't know which motor controller class fits with your motor controller, we'll go into more detail about what goes with what in the next video. If you're using the Talon SRX, the following code is how you can set one motor controller to duplicate the output of another. If you're not using a CAN controller, then all you have to do is wire the same PWM input into both motor controllers. First, we're going to create instances for each of the slave motor controllers. You can name these whatever you like. I tend to go with L slave and R slave to denote which sides they're attached to. We'll specify which motor controller it's a slave to later. Whether you're using CAN controllers or not, the next step is to create an instance of the drivetrain. The parameters for this are your left and right motors that you created at the beginning. Next, if we want to do anything when the subsystem is created, we have to create a constructor. In this case, you only need it if you're going to set one of the CAN controllers to be slave to the other one. To set a controller to slave mode, we just use, for example, lslave1.setControlMode and then talonControlMode.follower.value as the parameter. Note that at this point we've just told it it's a slave. We haven't told it which motor controller it should be duplicating. We can do this using the set function. We put the parameter as our left controller, and then we get the device ID for it to copy. Then we have to cast it to a CAN Talon, as our left controller is actually just a generic speed controller. Then we can just duplicate these two lines of code for the right side. Now that we're done with the subsystem class, we have to create an instance of it inside the robot class. Then we go to our OI class and create an instance of a joystick to control it. We're going to use the port number of 0 for this because it's the first one that we've created. After we've done that, we want to create a package called actions. This will hold the action that controls the drivetrain of the robot. Inside this package, create a new class named actDrive and set the superclass to action. Create a constructor and make sure that it's public because we'll need to access it outside of the package. We also should delete the parameter in there that appears by default. Replace the parameter in the superconstructor with new chFalse. This just means that the action will never end unless we tell it to. Next, we have to specify what we want the action to do. We can do this by overriding the onRun function inside the action class. Then, using the subsystem instance that we created inside our robot class, we can access the drivetrain and use the arcadeDrive function with the parameter of our joystick to make it move. If we wanted to use two joysticks to individually control the left and right sides of the motor, we could use the tankDrive function, and the parameters would be both of those two joysticks. Now that we've done this, we want to create one last class. Name it CommandList and set the superclass to CommandListStart, another Arachne class. This class will hold every command that we make. The first step is to specify the subsystem that this command will use. We can do this by just creating a static block and then setting a variable named subsystem to use to robot.driver. Every command below this block will use the robot.driver subsystem. Finally, we create a new command setup instance using the new com function. The parameters are just the action that we made, so new actDrive. The final step is to go back into our robot class and set the default command of the driver subsystem to the command that we just created in command list. We can do this with the subsystem name .setDefaultCommand and then access the variable stored in command list. Put the .c function on the end to create a new instance. You should now be able to drive your robot around using the joystick in port 0. In the next video, we'll look at creating other actuators.